There are very common mistakes people make when writing string comparison code in C. It works most of the time, but it's not completely correct. Let's write the basic strcmp function first and then fix it properly. We need to implement our own version of strcmp, and here are the rules. We do not want to use the standard library functions, and we want to compare two null terminated strings. Our function should return 0 if both strings are equal, a negative value if the first string is smaller, and a positive value if first string is greater. Let's start with the typical implementation and then we will improve it step by step. Let's write the function prototype first. Int my strcmp, and it accepts two pointers, const char star s1 and const char star s2. We want to compare two strings s1 and s2. Let's build logic step by step. Let's say we have two strings. The first string is say apple, and let's say we have apricot as second string. Apricot, again it is null terminated. Pointer s1 is pointing here and pointer s2 is pointing here. To compare these two strings, we'll compare each character one by one. So how do we compare each character? So star s1 equal to star s2. So we are dereferencing the pointer with star s1 to get the value a here, and star s2 will give the value of the second string. If both characters are equal, we'll move forward. Then s1 will point here and s2 will point here. So again, at this case, if both characters are equal, we'll move forward. s1 will point here and s2 will point here. At this stage, characters are not matching. So what we need to do? We need to return the difference. So we'll return star s1 minus star s2. Why star s1 minus s2? Because we need to return a negative value if the first string is smaller and positive value if the first string is greater. So in this case, p is smaller and r is greater, so it will return a negative value. So let's write the logic. Here we are comparing each character one by one. If the characters are equal, then we increment the pointer. If the characters are not equal, while loop will break and we return the value difference. This is how many programmers will implement this function, but it has two fundamental problems. Let's understand them one by one. This while loop is not correct. It will not work for all the cases. Let's understand with the help of one example. Let's say we have two same strings ABC and ABC. ABC, and second string is also ABC, and both are null terminated. So our S1 is pointing here and S2 is pointing here. Now as per this logic, A and A is matching, so we move S1 here and S2 here. Again B and B is matching, we move S1 here and S2 here. C and C is matching, so we move S1 here and S2 here. Backslash 0 and backslash 0 here is matching, so we move forward S1 and we move forward S2. Now at this point we are trying to dereference a pointer and it is pointing to a unallocated memory, so program will lead to a crash. So how do we fix this? We need to add one more condition here, star s1, and then this comparison. So if we add this condition, then how program will behave? Once we reach this backslash 0, this loop will break, so we will not cross the boundary. Writing star s1 is equivalent to writing this code. Star s1 is not equal to backslash 0. So we need to ensure that we don't cross the string boundary. This is the first problem. What is the second problem? Can you spot the problem? This return statement is not correct. Let's fix this return statement. It should be return unsigned char star s1 minus unsigned char star s2. We need to typecast it to unsigned char. Casting to unsigned char ensures correct behavior. Now let's see the complete working code. Here is my strcmp function implementation. It accepts two character pointers as an input argument, and in this while loop, the star s1 ensures that we are not crossing the string boundary. Here we are comparing each character one by one. If the characters are equal, then we increment the pointer. If the characters are not equal, while loop will break and we return the value difference. And we need to ensure that values are typecasted properly. Good programmers write code that works. Strong programmers write code that behaves correctly on every system.